Welcome back, students. So, in last chapter, that is light, reflection and refraction, we studied about the refraction of light through a glass slab. There, the incident ray is parallel to the emergent ray, but it is slightly displaced. Okay. For parallel refracting surfaces, as in a glass slab, the emergent ray and the incident ray are parallel, but they are slightly displaced, or the emergent ray is parallel to the incident ray, but it is slightly displaced, and that is known as lateral displacement. That is known as lateral displacement. So, how the light will get refracted through a glass prism? Glass prism. So, this one is a glass slab. Parallel sides are there. So, emergent ray will be parallel to the incident ray, but it is slightly displaced. That is known as a lateral shift or lateral displacement in case of glass slab. Now, this one is a glass prism. That is a glass prism. Triangular glass prism. So, how refraction of light takes place through this triangular glass prism? That we will discuss in this video. So, you have to consider a triangular glass prism. It has two triangular bases and three rectangular lateral surfaces. Two triangular bases and three rectangular lateral surface. So, this portion is a rectangle, this portion is a rectangle, this portion is a rectangle. So, three rectangular lateral surface and two triangular bases. This one is triangle, this one is also triangle. So, two triangular bases and three rectangular lateral surfaces are there for a triangular glass prism. These surfaces are inclined to each other. The angle between its two lateral faces is called the angle of the prism. So, here already a diagram is there. This one is a refraction through a glass slab. So, I will draw the triangular face. So, two triangular faces are inclined at an angle. So, this angle is known as the angle of the prism. Angle of the prism. Angle of the prism. Here, this angle represents the angle of the prism. Here also, this angle represents the angle of the prism. Normally, it is denoted by the letter A. For an equilateral triangle, angle of the prism is 60 degree. Okay, angle of the prism is 60 degree. Now, you have to draw the refraction of light through a triangular glass prism. So, here this one is the incident ray, this one is the incident ray. When it falls on this surface AB, here it is air, this one is glass. So, the ray of light travels from rarer medium to denser medium. So, it bends towards the normal. It bends towards the normal. Then, this one is a refracted ray. This one is a normal. This one is a normal at this point. So, the ray of light will bend towards the normal. So, this one is a refracted ray. When the refracted ray falls on the surface AC or falls on the side AC of the triangular prism, actually light ray will travel from a denser medium to a rarer medium. That means the light will travel from glass to air. So, it bends away from the normal. So, at this point, this one is a normal. So, it will bend away from the normal, and this is the emergent ray. That is the emergent ray. So, that diagram I will draw here. This is actually an experiment to do. So, first you have to draw the triangular prism. Name it as A, B, C. So, this is the incident ray. This is the incident ray. Incident ray. At this point, we need to draw a normal. Now, the light enters from air to glass, means rarer medium to denser medium. So, it will bend towards the normal. It will bend towards the normal. This one is a refracted ray, means a ray of light inside the glass prism. That is a refracted ray. For this space or side AC, the light will travels from denser medium to rarer medium. That is from glass to air. This one is glass, and here it is air, here also air. So, the light ray will bend away from the normal. So, at this point we need to draw the normal, and it will bend away from the normal. So, this one is a emergent ray, this one is a incident ray, refracted ray and emergent ray. Refracted ray and the emergent ray. Now, the angle between the incident ray and the normal at the face surface AB, angle between the incident ray and the normal at the side AB, that is the angle of incidence. It is represented by the letter I. It is represented by the letter I. Then here, angle between the refracted ray and the normal, this angle is represented by the that is known as angle of refraction, R1. This angle is also angle of refraction, R2. Now, this angle between the emergent ray and the normal at the face AC or at the side AC, that is the angle of emergence. It is denoted by the letter E. So, angle between incident ray and the normal, that is I. Angle between the refracted ray and the normal, that is the angle of refraction. It is represented by the letter R. The angle between the emergent ray and the normal, that is the angle of emergence. That is the angle of emergence. Just underline in your textbook, page number 192. You may note that a ray of light is entering from air to glass at the first surface AB. The light ray on refraction has bent towards the normal. At the second surface AC, the light ray has entered from glass to air, hence it bent away from the normal. Compare the angle of incidence and angle of refraction at each refracting surface of the prism. Is it similar to the kind of bending that occurs in the glass slab? For glass slab, angle of incidence is equal to angle of emergence. Here, angle of incidence is not equal to angle of emergence. The peculiar shape of the prism makes the emergent ray bend at an angle to the direction of incident ray. Because of the peculiar shape of the prism, the emergent ray bend at an angle to the direction of the incident ray, and that angle is known as the angle of deviation. So, what we will do is that we will extend the incident ray and we will extend the emergent ray also. So, this angle, that angle is known as the angle of deviation. That angle is known as the angle of deviation. Angle of deviation. So, this activity is there for you to do, and you have to do it in a paper and you have to paste it in your record. That's about the refraction through a glass slab and glass prism. In glass slab, the incident ray, in glass slab, the emergent ray is parallel to the incident ray, but it is slightly displaced. Here, due to the peculiar shape of the prism, the emergent ray bent at an angle to the direction of the incident ray. The emergent ray will bend at an angle to the direction of the incident ray, and that angle is known as the angle of deviation. That's about the refraction of light through a glass prism. Now, we will see the same light, means when sunlight passes through a glass prism, what will happen? What will happen? When sunlight passes through a glass prism, what will happen? Okay. So, what will happen is that when sunlight passes through a glass prism, you will get different colors on the screen. In the particular order, we will get different colors on the screen, that is violet, indigo, blue, green, yellow, orange and red. You will get violet, indigo, blue, green, yellow, orange and red on the screen. That short form is VIBGYOR. So, the colored band of the white light that is obtained on the screen is known as a spectrum of white light. You will get a band of colored components of the white light on the screen. That is violet, indigo, blue, green, yellow, orange and red. That is known as the spectrum of white light. That is known as the spectrum of white light. Sometimes you will be able to see all these colors distantly, but normally we can't see all these colors distantly. So, in other words, we will say when light passes through a glass prism, it will split up into its component colors. It will split up into its component colors. That is known as the dispersion of white light. Dispersion of white light. That also you just mark in your textbook, page number 193. The various colors seen are violet, indigo, blue, green, yellow, orange and red. The band of colored components on the light beam is called its spectrum. Then the splitting of white light into its component colors is known as dispersion of light. Means white light gets dispersed into 7 component colors. White light gets deviated or dispersed into 7 component colors. The reason for dispersion is that different colors will bend at different angle with respect to the incident ray as they pass through a prism. Different colors will bend at different angles with respect to the incident ray as they pass through the prism. Here this one is the incident ray. So, here this is a dispersion of white light through a triangular glass prism. So, this is a deviation for the red light. If I draw it, this is a deviation for the violet color. So, different colors will bend at different angles with respect to the incident ray as they pass through a prism. That is the reason for the dispersion of white light. Means different colors will have different wavelength. The wavelength of this one is from 400 nanometer to 700 nanometer. 400 nanometer to 700 nanometer. That is the range of our visible spectrum. So, violet will have one wavelength, red will have another wavelength. So, when it passes through a glass prism, it will split up into its different colors. That is known as dispersion of white light. The red color will bend the least and the violet color will bend the most. Here the deviation is maximum for violet. Here also the deviation is maximum for violet and it will bend maximum because the wavelength is minimum. This one is a violet. The wavelength is minimum. So, it will bend most or deviate most or maximum deviation is there for violet and this one is the wavelength of the red. So, wavelength of the red is more. So, the deviation will be minimum. Deviation will be minimum. If I draw it like this incident ray, this is a deviation for the red light and this is a deviation for the violet. So, deviation for violet is more since it is having less wavelength. Then for red, deviation is minimum. Then the speed of red color is highest and the speed of violet is least in a medium. Speed of red is highest and speed of violet is least in a medium. Now, Newton, Sir Isaac Newton in 1665 conducted an experiment to derive more colors from the spectrum of white light. Means he want to split the colors of the spectrum of the white light further by using another prism. Okay, by using another prism he want to divide the colors which we obtained during the dispersion of white light through a glass prism, that is violet, indigo, blue, green, yellow, orange and red. He wants to divide it further with the help of the another prism, but when he did the experiment, he could not get any more color. Then he placed a second identical prism in an inverted position with respect to the first prism. This allowed all the colors of the spectrum to pass through the second prism. He found that a beam of white light entering from the other side of the second prism. This observation gave Newton the idea that the sunlight is made up of 7 colors. So, that is known as a recombination of white light. So, what he did is he tried to split up these colors again and again by doing the experiment, but he did not get any more color. So, what he did is that he just placed an inverted prism just similar to the first one and allowed the white light to pass through the first prism. So, it will split up into 7 colors and the 7 colors is allowed to pass through the second prism, which is in an inverted position with respect to the first one. So, he observed that from the other side of the second prism, he got a beam of white light on the screen and he concluded that white light consists of 7 colors. So, the first prism is known as a This prism is known as dispersing prism. Dispersing prism means this prism will disperse the white light into 7 colors, and that 7 colors is allowed to pass through the second prism, which is in an inverted position. So, the second prism is known as a recombination prism. Recombination prism, and the light which we got from the other side of the second prism is of white. So, he concludes that white light consists of 7 colors. That's about this one is also, this one is a white light, this one is a, first one is known as the dispersing prism, second one is a recombination prism, and from the second prism you will get white light again. You have heard about Newton color disc. So, what is that? It is a circular disc and it is divided into equal 7 segments, and we colored it with 7 colors which are obtained in the band of the spectrum of white light, that is violet, indigo, blue, green, yellow, orange and red. When you rotate that disc very fast, instead of viewing it as individual colors, we will get a feel that it's white in color. It's white in color. So, when you rotate it fast, all the 7 colors appear to be mixed up and we will get a white light, that is due to the persistence of our vision. Okay, that is due to the persistence of our vision. So, that is about this refraction through a glass slab, glass prism, and dispersion of white light by a glass prism. So, we will not write anything in the notebook. We will draw the diagrams in the notebook and we will mark the questions and the answers in the textbook itself. Okay. So, students, just do it in the textbook and draw the diagrams in the notebook. That is for this topic, refraction of light through a glass prism, that is page number 192, figure 11.4. Then page number 193, figure 11.5. Then 11.6 also. 11.5 is about the dispersion of white light. 11.6 is about the recombination of white light. Okay. Thank you.